Let's go and take a look at problem number 5 in section 6.3. It says, in a survey of 4,013 adults, 738 oppose allowing transgender students to use the bathrooms of the opposite biological sex. Okay, the problem says to construct a 99% confidence interval for the population proportion and interpret the results. Okay, so based on the problem here, we see that there are 4,013 individuals in our sample. Okay, and the number who hold the belief that they oppose allowing the transgender students to use bathrooms of the opposite biological sex was 738. So the number of successes in our sample is 738. Okay, and we want a 99%. Okay, confidence interval for the proportion, okay, of all, okay, adults who have this belief. Okay. All right, so let's go and go to StatCrunch. All right, and we're going to go to stats, proportion stats, and then select one sample with summary. Okay, so the number of successes in our sample was 738. Number of observations, okay, was 4,013, and we're doing a 99% confidence interval. And we can include the plot of the interval, but it's not necessary. Okay, and this tells us what the confidence interval is. It's for the proportion. Okay, number of successes is here. Our sample size is here. Okay, and the proportion in our sample who have the belief is about 0.183 or 0.184 if you round it to 3 decimal places. So a little more than 18% in our sample hold the belief in question. Okay, so we're looking for the lower limit and upper limit of our interval. Okay, so the lower limit when rounded to 3 decimal places is 0.168. Okay, and then the upper limit when rounded to 3 decimal places, so 0.1996. Okay, so this 9 here, okay, the third 9 after the decimal point, I should say the second 9 after the decimal point, okay, is going to get rounded up to a 10. Okay, so that becomes a 0, but then you add the 1 here, carry the 1, so the 1 plus 9 is 0, so you carry the 1 again. So this actually gets rounded to 0.200. Okay, so the upper limit when rounded to 3 decimal places is 0.200. Okay, so before I answer the question of interpreting our results, okay, let's actually write the interpretation in Paint. Okay, so it's usually better to write the interpretation yourself and then select the best answer. Okay, so we are 99% confident, okay, that the proportion of all adults, okay, who oppose letting transgender students, okay, use the bathroom of the opposite sex, okay, is between, okay, our confidence interval limits, okay, which were, okay, 0.168, all right, and 0.200. Okay, so remember the interpretation includes the confidence level. Okay, the parameter we're estimating, which is the proportion. Okay, but then what is it the parameter or proportion of, right? What is it that we're looking at? We're looking at specifically the adults who oppose letting transgender students E is the bathroom of the opposite sex. Okay, so we include all of that along with the confidence interval limits. So we write that as a complete sentence. Okay, so we select the answer choice that matches the interpretation. Okay, so some of these answers are not going to make any sense. Okay, so remember the confidence interval is saying something about the entire population. Okay, right? We already have the results of our sample, right? We already know that, out of 4,013 adults, right, 738 hold the belief, right? So the confidence interval is for the population and not the samples, right? So that would eliminate choice D. So it looks like choice B, and you can read that carefully on your own, right? Feel free to pause the video. So let's check our answer. Okay, so answer choice B, right, most closely matches the interpretation that we came up with. Okay, remember, proportions, right, when they're expressed as decimals, right, can always be converted into percentages. Okay, so if it helps you make more sense of what this is, right, we can say that we are 99% confident that about 16.8%, I'm sorry, we are 99% confident that the proportion of adults who have the belief here, right, that they oppose letting transgender students use the bathroom of the opposite sex, right, is between 16.8% and 20.0%. Okay, so you can always change proportions expressed as decimals into percentages. Okay, if that helps you make more sense of what it is the confidence interval is doing. Okay, so I think we have time for maybe one or two more examples in this video. Okay, and it involves estimating or determining the minimum sample size needed to create a confidence interval for a proportion. Okay, so that's the last topic in this section. And it begins on page 324. Okay, which is once again finding a minimum sample size. Okay, so we're going to be using this formula here. Okay. All right, so the problem says a researcher wishes to estimate with 90% confidence the population proportion of adults who think Congress is doing a good or excellent job. Okay, and it says our estimate must be accurate within 2% of the true proportion. Okay, so before we look at parts A, B, and C, okay, let's summarize what the problem is asking. Okay, so in this problem, we want a 90% confidence interval for the proportion of all adults who think Congress is doing a good or excellent job. So our estimate, okay, which is the confidence interval, right, must be accurate within 2% of the true proportion of adults who think Congress is doing a good or excellent job. Okay, so it's important to note that in this question, right, we're not going to do a confidence interval, okay, like we did in the previous questions. Okay, rather we are interested in knowing how many people to survey in order to get the desired confidence interval. Okay, and we will use one of these two formulas below. In fact, we actually use both. Okay, so in these formulas, okay, the symbol N or the letter N represents the minimum sample size we are asked to find. Okay, so p hat is the sample proportion from a previous study or estimate if it's available. Okay, if a previous estimate for the proportion is not available, right, we would use this formula. Okay, but if we do have a previous estimate for the proportion, right, we're going to use this formula. All right, q hat is equal to 1 minus p hat. All right, E is the margin of error, which is given in the problem. Okay, that's this piece here, which is 2%. Okay, it's important to know that the margin of error, right, when you plug it into this formula, right, must be written as a decimal before you, before you plug it into the formula. And then Z sub C, okay, is the critical Z-score from the standard normal distribution for the given level of confidence. So that's where we use this to calculate or define this critical value. All right, and since it's a Z-score from the standard normal distribution, we're going to use the normal distribution calculator in StatCrunch to get that critical value. Okay, so going back to the question, part A asks, or says, right, no preliminary estimate is available, right? So find the minimum sample size needed. Okay, so to answer a question like this, right, where there's no preliminary estimate available for the proportion, we're going to apply this formula. Okay, so what we need then is that critical value and the margin of error. Okay, so again, this piece of the problem represents the margin of error, right, within 2%. Okay, so the margin of error is equal to 2%. So it's a decimal that's equal to 0.02. So hopefully you know how to convert a percentage to a decimal. Okay, if not, you can also look that up. It's quite simple. Okay, so then we need the critical values z sub c, which we're going to get from StatCrunch. Okay, which is for a 90% confidence interval. Okay, so we're going to open up the normal distribution calculator. Okay, we'll go to Stat Calculators and then select the normal. Okay, and we're going to select between. Okay, the mean and standard deviation are both 0 and 1 respectively, so we're not going to change those. Okay, but in this little box over here, we're going to select 0.90. Okay, our confidence level as a decimal. Okay. Okay, so the critical value we're looking for is positive. Okay, so these are both be the same, but one's negative, one's positive. Okay, so our critical value is 1.6449. So z sub c is 1.6499. Okay, so I'm not going to write down the formula here, but basically we're going to plug this into the calculator. All right, so we're going to type in 0.25. Okay, multiplied by, and then open up some parentheses, and then type in the critical value, 1.6499. Okay, divided by the margin of error e, which is 0.02. Okay, and we're going to square that. Okay, so I'm putting the whole calculation in. Okay, which may or may not work for you, but that's how I'm going to do it now. Okay, so we get this decimal number, so n is equal to 1701.356. Okay, so for these types of questions, right, we're always going to round our answer up. Okay, that's the important thing. Okay, so normally when we round, right, we would round this to 1701. Okay, but because we're dealing with sample sizes, right, finding the minimum sample size needed, okay, we're going to round that up to 1702. Okay, so if no preliminary estimate is available, right, we would need to survey this many people to create our 90% confidence interval with a margin of error of 2%. Okay, so again, when you round this up to the nearest whole number, right, it gets rounded up to 1702. Okay, so the answer to this question is 1702. Okay, so then part B says, what is the minimum sample size needed using a prior study that found that 26% of the respondents said they think Congress is doing a good or excellent job? Okay, so this 26%, okay, is the value of p hat, okay, that we're going to use in this other form. Okay, so p hat is equal to 26%. Okay, we're going to write that as a decimal, and that becomes 0.26. Now q hat, okay, which is equal to 1 minus that, so 1 minus 0.26, okay, it's 0.74. Okay, that's equal to 0.74. Okay, so we're going to plug all of that information in, including the margin of error and the critical value from the previous part, okay, to get our sample size. So in other words, the values for the margin of error e and our critical value z sub c are still the same in part B as they were in part A. Okay, so let's carefully apply that formula there. Okay, so we're going to do 0.26 times 0.74. Okay, so that's p hat times q hat. Okay, which is this number here. So let's break it down in pieces. Okay, so we can write that down or make a note of it. Okay, so now let's do z sub c divided by e to the second power. Okay, so z sub c is 1.6499 divided by 0.02. Enter, square it. Okay, square the answer and we get that number. And that's going to get multiplied by p hat times q hat. So which, remember, was 0.1924. Okay, that's going to give us our answer. But remember, we need to round our answer to the nearest whole number. So that's 1,309, but when rounded up, it becomes 1,310. Let's go and check our answer. And it's correct. The correct answer choice here is part B.